Hello everyone. Today I'll be presenting a simple yet effective way to find anagrams using Python. So we will explore how to implement this using standard dictionaries. First, let's define what anagrams are. Anagrams are words that can be rearranged to form other words. For instance, listen can be rearranged to silent and vice versa. Understanding this concept is crucial for our implementation. Our task is to find and group anagrams from a list of words. This is important in various applications such as text processing, puzzles, and games. So let's jump into how we can solve this problem using Python. So our approach consists of three main steps. We sort each word to create unique key. We use this sorted word as a key in our dictionary. And finally, we group words that share the same key. So this is the code block that does the above functionality. So we start by defining a function, find anagrams, that takes a list of words, and we use standard dictionaries to store our results. For each word, we create sorted key and group the words based on the key. First, these anagrams. So here we initialize this dictionary called anagrams. So this dictionary will store keys, that is the sorted words, and their corresponding list of anagrams. So here, this loop iterates through each word in the provided word list. For each word, we will perform operations to find and group anagrams. So here, this block of the code basically check if the key exists in the dictionary. That is, so if in the previous step, right, if we look into this step, create a key by sorting the word, right? So just I would like to mention two things. So it does two things. First one is sort the characters of the words in the alphabetical order. That is the sorted word functionality. Next, dot join does it joins the sorted list of characters back into the string. Okay, so when it comes to this piece of code, so what it does is basically if the key exists, see the key is coming from this one, right? So whatever may be the word, once we sort it, so suppose if we consider word one and its anagram, both having the same, both share the same key when we sorted and join by using this functionality. So if take that key and check in the anagrams dictionary. If that key exists, this line appends the current word to the list of words associated with that key. So if it doesn't, it newly creates that key in that dictionary and initializes it with a list containing that current word. And the final. So this line basically uses a dictionary comprehension to filter the anagrams dictionary. So it creates a new dictionary that includes only those keys whose associated lists contain more than one word. So indicating that they are anagrams. So for example, anagrams.items, right? If how this works. So it gives us a view of key value pairs. So we only include those pairs when length of words is greater than one, meaning we only want keys that have anagrams. So this is the example walkthrough. It tells us how that we can use this words list to navigate through that code to understand its fully functionality. So for example, if we take first word, listen. So it's like here, right? We are navigating for word in the word list, right? So pick one word, suppose listen. So the key becomes, so after the sorting, and joining, it becomes silenced. So the dictionary is created because this key is not there in the dictionary, right, earlier. So because that is empty dictionary for the first word. So similarly for the second word. So we should do all these steps individually to understand how that functionality. So please take this slide clearly so that we can understand that functionality of the code. And the time complexity, overall time complexity is order of O of nm log m. So for looping through words, there is O of n. For sorting each word, m log m, and dictionary operations is O of n, O of 1. So it's like since we are doing this sorting operation for n for every word in the n words, so it is order of nm log m. Similarly, the space complexity is O of nm because there we are storage for anagrams is nm because there are n keys. There could be n keys in verse here, and each one having m characters, right? So it's like, suppose, for example, if we want to navigate through space complexity, right? The overall space complexity is this. So this comes from the storage needed for the anagrams dictionary, which could potentially hold n keys, one for each unique sorted word. So each key might corresponding to m characters, so leading to total of O of nm. So it is also worth noting that while we use O of m space for the sorted key of each word, this is transient and doesn't accumulate across iterations. Therefore, it doesn't change our overall space complexity.